ASM Terni is a multi-utility company that owns and manages the electricity distribution network in the municipality of Terni in central Italy. ASM has decided to group 54 prosumers into a virtual power plant aiming to explore the potential of the network's loads for demand response. More specifically, this use case is intended to leverage the sources of flexibility in the area, and especially demand response, to reduce reverse power flow in the electrical distribution grid. During this process, various information is required such as load forecasts, user behavior and weather forecasts. In this context, throughout I-NERGY Task 4.4, ICCS developed an AI-based web application, named FlexDR, for flexibility forecasting and demand response. FlexDR comprises three main functionalities: short-term load and generation forecasting to predict the day-ahead user behavior, electrical time series clustering to perform prosumers profiling based on the provided forecasts, a smart and flexible recommendation engine that suggests appropriate demand response actions to prosumers, based on the cluster they belong to. In this way, the service can help leverage flexibility within the smart community and reduce reverse power flow. Note here that the models behind FlexDR were trained on load consumption datasets provided by ASM. Functionalities of the I-NERGY FlexDR application will be demonstrated on this video by illustrating potential use cases for the different user groups it supports. These user groups encompass energy experts, data scientists, as well as prosumers. Starting from the home page, energy experts can access the smart meters page through the side menu, where they can register the smart meters involved in the energy community. To add a new one, they can expand the Add New Smart Meter section, provide the necessary information about the smart meter, and confirm the registration. Below, there is the list of the smart meters that have already been registered. Users have the option to modify the smart meter details or remove them if necessary. Additionally, by clicking the Day Ahead button, they can access information about the Day Ahead cluster assigned to the respective smart meter. On this page, energy experts will encounter three main sections. In the first section, they will discover details regarding the model utilized for clustering the predicted load. This information includes the clustering algorithm employed, the number of clusters identified, the date of model training, and the time period covered by the training data. The second section provides an overview of the specific smart meter. The final section displays the cluster profile, which is calculated by the machine learning model based on the forecasted load for that smart meter's day ahead. This section includes a chart that illustrates the forecasted load and the load curve of the assigned cluster. The recommendation presented in this section corresponds to the cluster profile it matches with. However, if energy experts wish to customize the recommendation specifically for this assignment and depending on the type of the smart meter, they are able to it via the Edit Recommendation button. In order, users to create the cluster profile shown on this page should first navigate to Clusters Profiles page. Here they are able to create a new cluster profile for the clusters already identified by the AI model. At this point, energy experts can preview the load curves of the clusters calculated by the algorithm and, if needed, they can combine similar clusters to form a single cluster profile. To complete the profile creation, and after providing some descriptive information of the profile, users should provide the recommendation that suits the most to this specific profile. Returning to Clusters Profile page, users are able to view the existing cluster profiles and their details, including the clusters and their load curves, as well as to modify any of this information via the Edit button or even delete a profile. If users wish to review a historical log of the assignments that have occurred, they can navigate to the Assignments page. Additionally, if they require more information, they have the option to examine the details of these assignments. Now, let's consider a different situation where a prosumer logs into the application. When they log in, the page presents details about the user's smart meter and provides the daily tip based on user's predicted load. After having become familiar with core functionalities of the application, a high-level architectural diagram is presented. The data from the smart meters get stored in the MongoDB database, which also houses load forecasts generated by the load forecasting service. These forecasts are then utilized by the FlexDR backend as input to the ML model to obtain the cluster assignment. The machine learning model's lifecycle is managed through the MLflow server, in conjunction with MinIO and a PostgreSQL database. The implementation of the FlexDR web application is built upon a fast API backend service paired with a React frontend service. Identity and access management are handled using Keycloak and the OpenID Connect protocol. Thank you for watching this video. Join our network to learn more information about I-NERGY project.